Namaste everyone. Welcome to Wave Optics class. Today we will have class in the classroom itself. We have been discussing about the activities like interference, diffraction through all our PPT classes. Now today we will have some problems in this interference and diffraction. Some students asked me that you have to discuss the problems in the class. We don't understand it in the PPT form. So we will see a few more questions. And it is better we solve many questions because, namaste, we get many problems from this, or many a times the problems from this chapter in the examination. And problems are not so difficult also. So shall we move on? This is a problem. We have worked out, we have seen such a type of problem earlier. In an Young's double slit experiment, distance between the slits is 1 millimeter. Shall we go on writing the values? Take a pen and paper and calculator. With that, you sit in front of this either mobile or a laptop or whatever you are using and start working it out along with me. In an Young's double slit experiment, distance between the slits is 1 millimeter. So is it small d? You know the formula, beta, fringe width beta is equal to lambda d by d. D is the distance between the slits and the screen, right? This is capital D, and this is the place where central bright fringe is produced, and this is small d. You know all these things. And so fringes will be produced here, bright dark pattern will be produced, and the distance between two successive bright fringes is called beta, right? That is fringe width. Distance between two successive bright fringes or two successive dark fringes is called fringe width beta. Now d is given. Small d is 1 millimeter. Yeah, 1 millimeter. What else? The fringe width is found to be 0.6 millimeter. Fringe width beta is 0.6 millimeter. Okay. What else? When the screen is moved through a distance of 0.25 meter, the fringe width becomes 0.75 millimeter. So new fringe width beta dash is 0.75. You look into this form here. Fringe width has increased. When this is possible? When they say the screen is moved through a distance of 0.25 meter. Moved through a distance of, screen is here. When it is moved through a distance either towards or away from these double slits, whether it is towards or away, that we have to conclude. That is not given for us. We have to conclude it ourselves and decide whether we have to move it towards or away. And D, capital D comes in the numerator. If you want to have a more beta next time, when it's after making this change, if you want to have more beta, you have to make more d, because beta is directly proportional to d. So the new value of d dash, and I will write it as d dash, must be equal to d plus moved through a distance of 0.25, d plus 0.25, correct? It should be 0.25 extra, right? Right, 0.25 plus, okay. And is capital D given? No, nothing is given. Now you have to solve this, right? What is the wavelength of light used? Lambda is how much? So after increasing the distance of the screen or moving the screen through a distance, of course it should be away. We must know that it should be away, because without moving the screen away we couldn't get more d with more beta, right? So d plus 0.25. Write the formula for both the cases, then solve them. What is beta? First beta 0.6 millimeter. 0.6 millimeter must be equal to lambda capital D by small d, 1 millimeter. That is the first equation. Now later, when the new fringe width beta dash 0.75 millimeter must be equal to same lambda, no changing, no question of changing wavelength, that nothing is told about it. So you are using the same wavelength, right? Lambda is same. So lambda capital D, that is d plus 0.25, capital D by small d. Small d is 1 millimeter again. That is also not changed. only screen is moved. You see, you will be caught somewhere here, right? When the screen is moved through a distance, from there you will not be able to do what, you will not be able to think of what to do. So that is very simple actually. Just you have to get the glitch from this one. You have to solve that when beta should be increased, then the screen should be moved away, because they are directly proportional. Okay, this is the second one. You have to find out lambda. Now, don't come to the conclusion suddenly that we will divide the two equations. If you divide the two equations, of course, you will get capital D. Then you have to substitute again, you should get lambda. That is not wrong, it is correct. But instead, you can do that. You can subtract them so that you will get lambda directly. D gets cancelled when you subtract them. So, how to subtract this? This minus this. 0.75 minus 0.6. How much it will be remaining? 0.75 minus 0.6, 0.15 into 10 to the power minus 3. 0.75 minus 0.6 is equal to, so left hand side is over. In the right hand side, lambda by 10 to the power minus 3 is common. So I will write lambda by 10 to the power minus 3 common. Remaining things you have to subtract. D plus 0.25 minus D. D plus 0.25 minus D. Or you have to write this one minus this one. When you write this minus this, take the things common outside. Lambda by 1 into 10 to the power minus 3. Remaining is D plus 0.25 minus D. Gets cancelled. Only lambda will remain. And if you want to know what is the answer, lambda is equal to, bring this here, 0.15 into 10 to the power minus 6, minus 3, correct? Divided by, here only 0.25 is remaining. So that is 0.25. So shall I write 0.25 as 1 by 4? 4 comes to the numerator. What you will get? 4 into, that implies lambda is equal to 0.15 into 4 into 10 to the power minus 6. That is equal to 4 into 5, 20, 0.60 into 10 to the power minus 6. And if you want to put it in nanometers, multiply and divide by 1000 by 10 to the power 3. Multiplying by 1000, this makes 600, and dividing by 1000 makes minus 9. So it is 600 nanometer. That is the answer. So multiply by 1000, it becomes 600. This one minus 3, minus 9, 600 nanometer. That is the answer. So we have to be very patient, very calm, and we have to look into those sentences where it is teaching us and where it is just pricking us, and that sentence has to be elaborated. That is what you have to write. That's all. Finish. Yes. Shall we move on? Second question. Yeah. Here is the second one. Young's double slit experiment. In Young's double slit experiment, light of wavelength 550 nanometer is used to illuminate the slits. Okay, we will list the value. Okay, rub this. Light of 550 nanometer is used to illuminate the slits. 550 nanometer. Okay. The 10th bright fringe is at a distance of 0.025 meter from the central fringe. Suppose these are the two slits and this is the vertical position. This is 0th bright fringe, right? And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is the 10th bright fringe. So 1 gap, 2, 3, 4, 5, 6, 7, 8, 9, 10. What is this height? That should be 10 beta. 10th bright fringe is formed at a distance of 0.025 meters. And this will definitely give you what is beta. Beta is by 10, 0.025 by 10. So beta is 0.0025 meters. 10th bright fringe is formed at a distance of 0.025 meter from the central fringe. Calculate the distance between the slits. D is how much? And what is the distance of the third dark fringe from the central bright fringe? That we will take later. And lambda is given and the distance capital D is given. Capital D is 1.25 meter from the slits. Yes. Now what is beta is equal to lambda D by D. That implies, hope you are doing along with me, right? Just simply don't keep on watching me what I am doing. Simply do it yourself. What is beta is equal to lambda, where is lambda? Yeah, 550 nanometer 1.25 capital D divided by small d. Small d has to be found out. That is equal to beta, right? What is beta? It is 0.0025. 0.0025. What is d? Bring d here. 0.025 here. That implies 550 into 1.25 into 10 to the power minus 9 divided by, I will write it 25 into 10 to the power minus, or 2.5 into, anyway you can write it 2.25 into 10 to the power minus 4 I will write, and that is equal to d. D I have brought here, 25 into 10 to the power minus, okay, what else will remain? 5 5s are 5 1 10s are, correct? Then 5 2s are 5s are. What else will remain? D is equal to, you have to put this in, yeah, we will multiply this. Now shall I give 1 0 to this here? So what it happens now? There is nothing in the denominator except 10 to the power minus 4. 110 into 0.25, correct? 110 into 0.25 can be written as 11 into 2.5. So 2.5 into 11. I have given this 0 to 0.25. Friendship, right? That is equal to into 10 to the power minus 13, right? Minus 13. We get so much large number. No, not minus 13. Plus 4 minus 5. Yes, correct. Next, this will multiply this to 11. 11 5s are 55. 5 remaining. 11 2s are 22. 27. 275 and 1 dot here into 10 to the power minus 5. We have answer here 0.275 millimeter. Milli means you have to, you have to remove 10 to the power minus 2. Then 10 to the power minus 3 will remain. When you remove 10 to the power minus 2, you have to divide this by 100. 0.275 millimeter. It's correct. So out of 10 to the power minus 5, take 10 to the power minus 2 and donate it to this one. Remaining 10 to the power minus 3 millimeter. And minus 2 will make it 0.27. Answer is correct. One part is over. Their question is another one. What is the distance of the third dark fringe from the central bright fringe? Okay, I will just change this one. Third dark fringe they want, right? What is the distance of the third dark fringe from the central bright fringe? Suppose this is bright 1, bright 2, bright 3 and bright 4, like this. Suppose this is dark 1 here, dark 2, dark 3. Where is dark 3? Dark 1 is at half beta because this is beta. Because central one is bright fringe. So from central bright fringe to the first dark fringe, half beta. Then here to here 1 beta. Here to 1, here 2 beta. 2 beta and half beta. So third dark fringe is at 2.5 beta. Where is the fourth dark fringe? Here. It is 1 beta, 2 beta, 3 beta, and then this remaining half beta, 3.5 beta. So every nth dark fringe is at n minus half beta. That's all. Every nth bright fringe is at n beta. Where is the first bright fringe? 1 beta. Second bright fringe? 2 beta, 3 beta, 4 beta. Seventh bright fringe? 7 beta. That is what we were discussing in the PPT class. There you were not able to see my face. Now you can see my face and you can understand it in whatever the way you want to be, right? Want to understand. Right. Now, nth bright fringe is always at n beta and nth dark fringe is always at n minus half beta. And in some books you will get n plus half beta. The distance of the nth dark fringe is n plus half beta, where this n is one less number they will use. For example, if they want to use, if you want to use this formula, n plus half beta, distance of the nth dark fringe, they will say, suppose it is the 7th fringe, put n equals 6. That's what they say. But answer is same, 6.5. But correct answer, correct one is this one, because if it is nth fringe, then that n should be the same nth fringe. Seventh fringe, 7 minus half, 6.5 beta. So what is the distance of the third dark fringe? It is 2.5 beta. Distance of third dark fringe is 3.5 beta. Beta is already given, 3.5 into beta is 0.0025. So multiply them, you will get that answer, 0.00625. You check it yourself, okay? And you can use the calculator, no problem. So you will get that answer. So that is about the second problem. Now, shall we move on to the third one? Ready? Yes. Okay, third one. The interference experiment. There are two slits, okay, we know it. The slits are 2 millimeter apart, okay, we will list them. Let us not waste the time, we will list them. So you list it in your paper. Don't simply waste the time by gazing at this video. Just simply go on writing it. Distance between the slits is 2 millimeter. They are illuminated with two wavelengths, yes. Two wavelengths of light. One like this, yeah. Here is the screen, slits, S1 and S2. And there are two sources of light here. This is the vertically opposite point. This should be the bright fringe, central bright fringe. Now the question is, they are using two wavelengths of light. One is 750 nanometer. Say 750 nanometer is written like this. So this is 750 nanometer. Hope you can see this. And another one is, you can see this, right? Yeah, you can see this. 750 nanometer, and another one is 900 nanometer. But both are not switched on simultaneously, one after the other. At what minimum distance from the common central bright fringe? On a screen 2 meter away, on a screen 2 meter away, the fringes of one interference pattern coincides with the fringes from the other. So we will use the same apparatus for both the sources. Now switch on 750 or 900 nanometer. This color light, switch it on. Light passes into both the slits and they pass out from the both the slits, interfere and produce the brightest red here, right? Where is the next bright red? Where is the path difference of 1 lambda? 1 lambda path difference is found somewhere else or somewhere here. So next bright red will be say somewhere here. This is next bright red, bright 1, bright 2, second bright fringe, third bright fringe, fourth bright fringe, like this. They are produced. Switch it off, switch it off. Switch off the red one. Switch on the blue one now. Or it is not blue, 750 nanometer is not blue. Switch on the 750 nanometer. What happens? It will form its own pattern. Blue colored light or some other colored light will start passing through this. And now red, the other one is switched off. So it will form its own bright here. It should be a bright fringe, right? Central fringe is always bright because for all the wavelengths there is no path difference here. What about the next bright fringe formed by this lower wavelength light? It will be shorter in distance because beta is equal to lambda d by d. There is no difference between d and d for both the sources because setup is same. What about lambda? Lambda is different for different sources. So beta should be different. How different? If lambda is less, beta is also less. So lesser wavelength will make shorter and shorter fringes, nearer and nearer fringes. Longer wavelengths, higher wavelengths will make far away fringes. So where is the next bright fringe of blue? It will be lesser than the first one of red. So B2, the next one will be here B3, and next one will be here B4, and next one will be here B5. Now you see, this is just an example I am giving. This situation may not be the same, but in order to understand, I will explain it like this. Now you see, if you go on marking it on the screen, switch on this one, mark all the red bright fringes. Switch on this one, mark all blue bright fringes. You find that the fifth one for blue and red, third one for red are formed at the same place. Oh, sorry, numbering has gone wrong. Why did I number it as 2, B0, Numbering has gone wrong. Okay. B0, B1, B2, B3, B4. Yes. Fourth of 750 nanometer, third of 900 nanometer are formed at the same place. That is what they are asking. What is that distance where both the fringes coincide? This is X. Very easy. And remember, for shorter wavelength, it needs more fringes to cover that point. For a longer wavelength, it needs only lesser fringes to cover that point. You can follow it, because sometimes after writing the formula we will get confused. Now let us say that it is the mth fringe for this one. So this is 900 nanometer. I have written here 900 nanometer, and here I have written 750 nanometer. Okay. Say this is the mth bright fringe. Okay. What about this one? Nth bright fringe. Let nth bright fringe of nth, or shall I, okay, I'll wrap this and shall I write it here only? Let nth bright fringe of nth of 750 nanometer and mth bright fringe of 900 nanometer are formed at the same place. Same point. That means n beta 1 beta, 2 beta, 3 beta, 4, 1 beta, 2 beta, 3 beta, 4 beta. 4 beta for this, 1, 2, 3 beta for other one. N beta 1 of this one and m beta 2 of this one must be same. Correct? Am I right? That implies, we'll write the formula. N of beta 1. What is beta 1? Lambda 1 d by d. Wavelength different, setup same, d. These are all same. Must be equal to, what is mth fringe of the other one? M lambda 2 d by d. Okay. So this capital D gets cancelled, small d gets cancelled. Finally what you will be left with? For entrance examination you have to start from here. Directly you have to start from here. You must get familiar with all these problems solved earlier itself, and then you have to start it all of a sudden. Okay. So n lambda 1 is equal to m lambda 2. Shall I rub this now? I hope you have followed this one. So n lambda 1 must be equal to m lambda 2. N into, or n by m must be equal to lambda 2 by lambda 1, 900 nanometer by 750 nanometer, 0 0, 15 5s, 15 6s. This is where we have caught off in one of the problem and dealing with PPT, right? We just didn't divide it completely. I didn't divide it completely, and I kept in some ratio like 56, 65. It may not be so. Some numbers, single numbers. Okay. So n by m is equal to 6 by 5. What do you mean by this? So conclusion of this should be very important. N by m is 6 by 5. What do you mean by that? See, sixth fringe of which one? 6 fringes are needed to cover that distance. Means the fringe width should be lesser and lesser. This is only fifth is enough. Sixth fringe of it should be 750 nanometer. Fifth fringe of 900 nanometer, larger steps. Now enough. So fifth of which one? 900, and sixth of how much? 750 nanometer are formed at the same point. Now come to the problem and we will answer it. We will rub everything here. You can come back in the video, you can see this again. I'll rub it now, no problem. Right? Now the question is, at what distance from the central bright fringe will they coincide? Find out any one beta and multiply it to find either 5 or 6. So shall I use 900 nanometer? Shall I use this one? if I use 900 nanometer, what is beta? Beta is equal to lambda d by d. Lambda is 900 nano. Capital D is 2. Small d, not given. Small d, slits are 2 millimeter apart. 2 millimeter apart. They get cancelled. So it is 900 into 10 to the power minus 6 meters. Okay, minus 3 I will give it here, 0.9. Beta is equal to 0.9 into 10 to the power minus 3 meters. I'll minus 6, minus 3 I will give it to 900, divided by 1000, 0.9. Then minus 3 will remain. This is beta. Now, how many betas for 900? How many betas for 900? Betas, only 5s are enough, right? 5 betas are enough because larger 900 steps. So 5 betas. So distance x, what I have written here, x should be equal to, it is 5 beta, 5 is m, right? M is 5, isn't it? M, yes, I have written here m. Yes, m beta, that is 5 into 900, 0.9 milli, correct? 0.9 milli. What is this? X is equal to 4.5 millimeter, right? It is 4.5 millimeter. It is at that distance. Sir, if you go to the other case, will you get the same answer? Definitely we will get the same answer. We will check it if you want. I will take 750 nanometer. I will rub this diagram. It is consuming space. Okay. Will it be at the same place, sir? Yes. The distance should be same. Beta for 750 nanometer, what is that? Lambda 750 nanometer, capital D 2, small d 2 millimeter. So what is this? Gets cancelled, and if you bring it here minus 6, so beta is 0.75 millimeter. And it is the 6th fringe, right? It's 6th fringe of 750. So x is equal to 6 beta, I'll write dash dash. That is equal to 6 into 0.75 millimeter. Is it same as that distance? Should be. 6 5s are 30, 45, and 2 places 4.5 into 10 to the power minus 3 meters, 4.5 millimeter. You get the same answer, no problem, right? So that is how you have to solve it. And these are all the types of problems that you will get it in the exam, even in the theory exam as well as entrance. For entrance exam also this is helpful. Okay, shall we move on? Yeah, we have enough time. Yes, 4th one. Yeah, this is related to diffraction. We will take the problems of diffraction on. How did I say that this is related to diffraction? Incident on a narrow slit, single slit, no double slits. A parallel beam of light of wavelength 500 nanometer falls on a narrow slit, and the resulting diffraction pattern is observed on a screen 1 meter away. It is observed that first minimum is at a distance of 2.5 millimeter from the center of the screen. Find the width of the slit. Read it again. Of course, this is in the sheet or PDF that I have sent already. It is in the PDF. I don't know which number problem it is, but it is there in your WhatsApp message. You can download it. It is there already. A parallel beam of light of wavelength 500 nanometer, lambda 500, falls on a narrow slit, and the resulting diffraction pattern is observed on a screen 1 meter away. So it falls on a narrow slit like this here, and falls on a screen 1 meter away. I will take it as capital D here, and a parallel beam of light falls on this. Wavelength is given, slit width is not given, A, that is, find the width of the slit. Yeah, when the light falls here, you will get maximum light, right? And as you move away and away, the intensity of light goes on decreasing, and here also it goes on decreasing. So the brightness and so like this. Intensity variation with the distance can be written like this. So this is the brightest position here, and this is called central maxima, this is first minima. The other data is It is observed that the first minimum is at a distance of 2.5 meters. So this is the central maxima. Here, this one, the first minimum is at a distance of, this is minima, brightness is 0. You can follow this graph, I think, right? The first minimum is formed at a distance of 2.5 millimeter from the center magma. I call it as X. Okay, now if you observe from this slit, from the slit, if you just start observing it, if you can see this brightest region here, at what angle it will appear? That is called angular width of the central maximum. This theta corresponds to the angle at which the ray has been diffracted, the angle of diffraction, because as soon as the parallel beam falls on the slit, this is the slit, this is a thick metal plate with a small hole here, right, like this, and this slit is having a width of 2a, that gap is 2a, and when the light falls on this, not only some light falling moving forward and in a straight direction and falling on the slit, you can observe the light which is bent like this and moving like this. That is called diffraction, bending of light around the narrow obstacles. Here the light bends around the narrow slit, and that light bent at an angle theta may form a dark fringe also. What is the condition for formation of dark fringe here? A sin theta must be equal to L lambda, and the first dark fringe is formed at A sin theta is equal to 1 lambda. First dark fringe. Till that you will have bright fringe. So brightness goes on decreasing, becomes perfectly dark. On the other side also, they say that the first dark fringe is formed at a distance of 2.5 millimeter from the central bright fringe. From the center of the screen, next bright fringe is at a distance of 2.5 millimeter. Okay, A sin theta is equal to 1 lambda, we will take it. And also you know that in all these cases, the diffracted beam from the original direction is bent in such a small angle, because if you try to get the diffracted beam with larger angles, their intensity is very less and you can't see them at all. Only very less angle diffracted beams are little bit intensive, otherwise others are not at all seen. So when theta is small, what you can write, sin theta is almost equal to theta, so A theta is equal to lambda. Now try to get this theta in terms of this, finish, because this is given. So when you have an arc of a circle like this, so if you have an arc of a circle of radius r, suppose the length of the arc is L, and if this arc subtends an angle theta at the center, you write L is equal to r theta, right? So when a radius r subtends an angle arc as an angle theta like this, and making an arc of length L equal to r theta, apply this here. This x is equal to d theta. Shall I write it? So I will take it as equation 1. X equal to d theta. I want to get theta here. X equal to d theta. You can get theta because theta is x by d. X is given, d is given. Theta is equal to, x is 2.5 millimeter and d is 1 meter, right? So substitute this theta here, you will get A. So what is the answer? What is the question here? What is the wavelength of light, right? Find the width of the slit, sorry. So A theta is equal to lambda. A width of the slit to be found out. Theta is 2.5 millimeter is equal to lambda 500 nanometer. 500 nanometer. So what is A? A is equal to 500 nano divided by 2.5 into 10 to the power minus 3. So bring it here. 25, if it was 25, it would have been 20 times, right? 2 times 50. Now 2.5 2 times 0, 0. That is equal to 200 into 10 to the power minus 6, minus 3 and minus 9. Minus 3 becomes plus 3. Plus 3 10 to the power minus 9. 10 to the power minus 6. This is 0.2 millimeter, because donate minus 3 here. Remaining minus 3, keep it as it is. 0.2 into 10 to the power minus 3 meters 0.2 millimeter. So that is how we analyze it, right? So that is the angle of diffraction, theta, and that has to be equated to L is equal to R theta. Okay, shall we move on? Yeah. Problem 5th. Width of the central maximum of a diffraction pattern produced due to a single slit of width 0.2 millimeter is 15 minutes of an arc. Here we get stuck with 15 minutes of an arc. What do you mean by 15 minutes of an arc? 15 minutes of an arc means 15 minutes. Say, this point moves in such a way that about the center, it produces 15 minutes of an arc. That arc, the two ends of the arc make an angle of 15 minutes at the center. 15 minutes of an arc. Width of the central maximum of a diffraction pattern produced due to a single slit of width. So width of the slit is given. A is 0.2 millimeter. Right? You know there are slits. So there is a slit here. Parallel beam of light is made to fall on the slit. It is diffraction. And directly above the slit there is a screen, and here is the central maximum, and brightness goes on decreasing as you move away from the slit. So like this, less brighter, less brighter, highest brighter. The explanation is single slit of width is given 15 minutes of an arc. What do you mean by 15 minutes of an arc? Yeah, it is where is the chalk? Yes, this is a small width slit. Yeah, right, like this. Look into this. This is the diffracted beam till the first dark fringe. This is theta, angle of diffraction. This is the direct beam, this is the diffracted beam. Do you agree? And this is the first dark here. Now here, compared to this problem and the previous problem, you have to note down the difference. You see the previous problem. In the previous problem, the distance, here you see, a parallel beam of light of wavelength is inserted on a pattern observed on screen. Distance, first minimum is at a distance of 2.5 millimeter from the center of the screen. From the center of the screen, the first minimum is at a distance of 2.5 millimeter from the center of the screen. No doubt at all. This should be 2.5 millimeter. But here you see, next problem. The central maximum of a diffraction pattern produced due to a single slit is the width of the central maximum of a diffraction pattern produced due to a single slit is 15 minutes of an arc. Width of the central maximum is 15 minutes of an arc. That means if you keep your eyes here and observe this central maximum, the brightest fringe like this, it produces an angle which is 15 minutes. So this is 15 minutes. This angle is 15 minutes of an arc. Arc is this one, the full central bright fringe. It produces 15 minutes of an arc. Now, what theta we write here is 15 by 2 minutes. Am I right? Correct? It is 15 by 2 minutes. Only the things you have to take care of here is, one is this one. It is the full angular width. And here the width means it is the angular width. When you look into the, for example, if you are looking at this question, how much angle this, the width of this paragraph makes in your eyes. A line drawn from here to your eyes, another line drawn from your eyes, how much angle does it create? And if the writings were up to this, that will create more angle. So how much angle is created? That is the width, angular width, not the linear width, not the width in meters. Last time it was in meters. Now it is angular width. Width of the central maximum of a diffraction pattern produced due to a single slit of width 0.2 millimeter. So A is 0.2 millimeter. E is 15 minutes of an arc. So angular width is 15 minutes. This theta is only 15 by 2. Now you can apply all the things that you know, but only the thing is, this is in minutes, that has to be converted into radians, because if you want to put it into sine theta, if you want to write sine theta almost equal to theta, then only theta should be in radians and very small. It should be radian small angle. So if it has to be so, how to convert it into radians? 15 by 2 minutes means divide it by 60, it becomes degree, so many degrees. For example, 30 minutes, half degree. Why it is 30 minutes half degree? 60 minutes is 1 degree. 30 minutes is half degree. Because 60, when you divide 30 minutes by 60, you get half degree. Okay, divided by 60, it becomes degree. Then convert it into radian. How to convert it into radian? Pi by 180. So 15 by 2 into 1 by 60 into pi by 180 radians. Now this is ready. Okay, now this angle theta is ready till this. But it is not tough. You must know this earlier itself, because in the examination all these things, oh, I came to know that I have to convert it into radians and I did it. It is very difficult to imagine such a case. You should have a knowledge of doing this earlier itself. So one thing is, it is the full angle given, angular width of the central maximum. They didn't say that half angular width of the central maximum. Full angular width of the central maximum is 15 minutes of an arc. So we need only half angular width, 15 by 2 minutes. 15 by 2 minutes is 1 by 60th of a degree and pi by 180 radians. Everything is ready. Now come here. What is the condition for the formation of the first dark fringe? The diffracted beams should move at an angle such that A sin theta is equal to n lambda. Since it is the first one and theta is very small, what I can write? A theta is equal to 1 lambda. Because this is the first dark fringe and the angle of diffraction is very small, sin theta is almost equal to theta. Now A is given 0.2 millimeter, 0.2 millimeter, and into theta is ready. That is 15 by 120, this one, into pi I can write it as 3.14 by 180. This pi is 3.14 by 180. So 15 by 120, 3.14 by 180. A theta is over. That is lambda. That is what is asked. And we will calculate. Let us see whether we get approximately of this, because I don't have calculator. If you have calculator, please check it. Will you get the same answer? What I will get is lambda is equal to 0.2 into 10 to the power minus 3 into 15 into 3.14 divided by 120 into 180. Let me check it. Shall I get it or not? 2.1 times, 260 times over any, shall I take it as almost 3 1 times, 320 times, okay, and 15 1 times, 3 remaining 2 times over, everything is remaining in the denominator, so you have to divide somehow. Lambda is equal to, so we will write it once, 10 to the minus 1 minus 4 divided by, this is 240, 12 0 240. Okay, if it is 240, okay, that is equal to, I'll bring 1 0 to the numerator. What happens? 10 to the minus 3, no, minus 5 divided by this 0 here donated, 10 to the minus 1 minus 5 by 24. But if you take it as 25, if you take it as 25, 1 by 25 is, so shall I write it here? Here, 1 by 25 approximately as 10 to the power minus 5, that is equal to 1 by 25 is 0.04 times, right? 4 times into 10 to the power minus 5. We don't get nanometers. We may get it. So this comes to 1 2, yeah, 4 zeros, you bring it here, 400, right? Oh no, yeah, 400. Then how many places you will get? 1 2 3 4, yes, 10 to the power minus 9. You will get it. But I didn't get this answer because I didn't divide it correctly. You divide it using calculators. you will get the answer. So that is fifth problem. But see, and there are similar questions in that PDF. Try to do them, because very important questions. Okay, so that is about the problems in this chapter. And if you want, I will work out few more problems. That is not a big task, but you have to keep remembering it till that examination. Classes themselves have not started, but you have to do that. But definitely those who are working hard, working to the time, are definitely some 10 steps ahead of those who are not doing anything, because we don't know how the rules may be changed. There may not be anything sympathy like these are the kids and we should slowly teach them. Once the classes start, then there may not be any time for anything. You will have to keep on running. So better to study it now only. Hope you are doing all these things. Hope you are following all these things. I am very happy to see that many students are following and asking questions, asking doubts, still keeping in phase with me and coming along with me. So study them properly, and thanks for watching. Keep your health very safe. Right? Don't go move away, because now this is the time where we have to sit inside the house only. Don't move away anywhere. So we will meet in the next class with few more ideas, few more problems. Thanks for watching. Thank you.